All right, Algebra 2, welcome back to part 2 of CFR2. So far what we've done in part 1, we've talked about the increasing and the decreasing. We've talked about the hills and the valleys. We got a few other things that we need to talk about when we're just describing functions and function graphs here. So in this case, what I want to do is move on. We're going to use the exact same graph. Going to use the exact same graph here. And I want to kind of make this noticed here. Actually, let me go back to the first page. Also, take a look at the relationships between the increasing and decreasing intervals and the hills and the valleys, right? They describe each other. Negative infinity to -6, -6 to -4. Well, from increasing to decreasing, we had a maximum. We had a hill at -6. When x was -6, we had a hill. And then we had from decreasing from -6 to -4 to increasing -4 to -1, we had a valley right down here. We had a valley, right? These things work together. Just like we go from increasing to decreasing again, we had that hill at 6. And notice how when this goes to infinity, when 6 went to infinity, we did not have a hill or a valley. Same with the beginning. There's no hill, there's no valley. We don't have relative maximums there, okay? We're not talking about the global, the full maximum. We're talking about relative maximums. Now that we've kind of touched on that or retouched on that, let's look here. We've got four more little things that we're going to use to describe this one. We already know what x-intercepts are. We've done this in Algebra 1. We've done this in Algebra 2 now. X-intercepts, you also may have heard these or will hear these called our zeros, the zeros of our function. The zeros of our function. I'm going to use a different color. This one. The zeros of our function. And it's literally, it's saying, where does it touch or cross the x-axis? Where does the function, there we go. Where does the function touch or cross the x-axis? Where does the function touch or cross the x-axis? And literally all you're doing is saying, well, it touches right here, crosses here, it crosses here, it crosses here, it crosses here, and it crosses here. It crosses 1, 2, 3, 4, 5 times. It doesn't just go down and touch it at all. It crosses every time. So you're just going to write those values down, the x values, because in an x-intercept, we already know the y value. An x-intercept has a y value of 0. So it doesn't matter if the x-intercept is -4,000, we know the y value is 0. In this case, we have 1, 2, 3, 4, 5 x-intercepts, and these are -7, -5, -2, 4, and 8. Notice how I'm not putting parentheses around these. These are not coordinate points, and these are not intervals. I'm just making a list of these things. If you're writing a coordinate point or an interval, the parentheses are very, very important. Here, it's just a list. It's just a list. And now we've got something interesting going on here, right? The next part says, on what intervals, again, we're talking the x intervals, on what intervals are the function values positive? In other words, where is f of x or y? Where is f of x or y positive? Where is f of x or y / y, we'll do this one, positive? And here's the thing, positive y values, oh, no, not quite. Positive y values are values that are above the x-axis. So it's all the values up here. These are positive y values or f of x values. These are positive, right? Oh, nope, I don't want to do that. There we go. These are positive values. And so what we have to say is, look, it's positive. It is positive between here and here. It's positive between -7 and -5. There's that hill that's up there. So it's positive. This case, we're going to write it out in an interval again. We're going to list the intervals that make this true. List intervals. List x intervals. We'll even do that. X intervals that make this true. List the x intervals that make this true. So where are they positive? From the first interval, they're positive up here between -7 and -5. We've got a positive function. Well, there's also a hill that's above here between this point and this point. These 2 points right here, right in here, are also positive. So from -2 to 4 is also positive. Anything else that's positive? Anything else in this green area? Oh yeah, from 8 until doesn't stop. What's doesn't stop again in X or in general? Doesn't stop is positive infinity. So it's also positive from, what did I say, 8? From 8 to positive infinity. I would like to point out we have some of these values. We've seen some of these already, haven't we? -7 went here, -5 was here, -2, 4, 8. Interesting. It's like I've planned these to work together somehow. It's amazing. All right, let's look at the opposite side then. Where is the function negative? And so I'm just going to put a little highlighter on here. Let's go whatever color that is. Negative x value or y values are below the y-axis. So anything down in here is a negative y value. Oh, it feels like art class all over again. Just coloring and coloring, and I didn't even stay in the lines, but I'm the teacher, so I don't get in trouble right now. It's my artistic interpretation. So anyway, anywhere you see there, let's go ahead and highlight this. Those are negative intervals. In other words, let me go ahead and rewrite this here. Let me rewrite this. In other words, where is the f of x? Where is f of x or y, however you want to think about it, negative? And what do? We once again, we're going to list the x intervals. List x intervals that make this true. And so let's look in here. Let's look in here. Well, it's negative. This function is negative. It stays from negative infinity, right, in x up until right there. This function is negative. So from negative infinity until -7, this function is negative. And the other places that it's negative. Oh, hey, right in between here, in between these 2 points, the values are down below the x-axis. So from -5 to -2, those are negative function values. Anywhere else? Anywhere? Whoa. Okay. So, yeah, I know. Different shirt, the whole 9 yards. Okay. So I made a mistake the first time. I'm going to make sure that that's in here correctly. This is negative from 4 until 8 also. See how the values are below the x-axis? So from 4 until 8. Okay, so from 4 until 8 right here. Now they're written in correctly. They weren't before, all right? So if you've already watched this, you might have, if you've already watched this, you know what I'm talking about. If you haven't, okay, it's from 4 to 8. And this takes me from negative infinity to -7, Then I come up here, positive from -7 to -5. And then something's going to happen from -5 to -2, which does right here. And then from -2 to 4 happens here. And then something's going to happen from 4 to 8. Those are negative. And then from 8 to positive infinity. And we've covered the entire number line. So we've got the entire domain of this function. Because if you look, if I'm doing the domain here, it goes from negative infinity to positive infinity because I've got the arrows that indicate I'm going to have x values that have y values at those spots. Okay, now back to the regularly scheduled fleeced Mr. Brayman. This last part is kind of fun. It's the average rate of change. We've done rate of change. We've done rate of change already, but we're going to take it and do a little something more with it. So what's the average rate of change? All I'm looking for, all we need to know is be able to describe the rate of change or the slope between 2 points. Rate of change or slope between 2 points. In other words, I'm just saying, let's say I want you to tell me, where do I have a positive rate of change? All you have to do is pick 2x values that give me a positive rate of change. I am looking here, and I am saying there is a positive range between when x is -7 to when x is -6, because that rate of change would be right here. So between those two values, and again, I'm just going to do identify an x interval, right? We're going to identify, yeah, let me rewrite this here. We're going to identify an interval. There we go. Headset turned off. All right. Identify an interval with the following characteristic. I would like one that has a positive rate of change. I need one with a negative rate of change, ROC, and a 0 rate of change. In other words, a horizontal rate of change. And so what do these look like? Again, we're just trying to do two x values, between two x values that give us a positive rate of change. Up here, I picked between -7 and -6 because the value for -7 is right here. The value for -6 is up here. If I draw a line between those 2 points, I get a positive slope because it goes uphill. So I said -7. So an example would be from -7 to -6. And since it's an interval, I do have to put the parentheses around it. Now, there are an infinite number of positive rates of change in this one. How about a negative rate of change? Just make it easier on yourself, though. Here's a negative rate of change. If I go from, I don't know, how about from here to here? And I need to describe the x values. So from 1 until 6 in x, that's going down. So if I drew that between those 2 points, that would give me a negative rate of change. So I'm going to say, again, an example would be from 1 to 6. Again, where is it going down? Your answers are going to vary. Whatever you pick is fine as long as it's positive, as long as it's negative, or in this case, as long as it's 0. Well, let's look at 0 here. A 0 means a horizontal line. The easiest way to do this, the most straightforward way to do this, is to pick 2 x-intercepts. Why is that? Because if I pick this x-intercept and this x-intercept, or how about this one? How about between -2 and 4? That is a horizontal line that has a 0 slope. So I'm going to say between -2 and 4. My example is from -2 to 4. But again, for here, answers may vary. As long as you've picked a spot, as long as you picked an interval that fits the description, a positive, a negative, or a zero rate of change, as long as you pick the description, you're good to go. You're good to go. All right, what's another way we might look at this whole rate of change business? Well, we might have something like a table, a function, a table of a function value. Okay, so in here, when x is 0, y or f of x is 50, 175, 240, and 365. So if I go from x is 0 to x equals 1, that's an interval, right? If I'm going from there to there, my rate of change would be what? Well, if you want to, sketch it out. 0, let's call this, 25, 50, 75, 100. 25, 50, 75, 100. You could do the slope if you wanted to. I don't need to know the value. I just need to know if it's positive or negative here, right? It says, because on which intervals is the function's average rate of change positive? Select all that apply. So 0, 50, let's call this what? 1, 2, 3. 1 is 75, 2 is 40, and 3 is 65. So this is saying from 0 to 1, from x is 0 to x is 1. That's that line right there. That's that rate of change. That right there, that is a positive rate of change. How about from 0 to 3? From 0 to 3. Well, looking there, that's also a positive rate of change. And how else would I know that? Well, the second value is bigger. 75 is bigger than 50. 65 is bigger than 50. That's positive. How about from 1 to 3? From 1 to 3. That one looks pretty negative. And look, 65 is smaller than 75. This would be negative. From 0 to 2. From 0 to 2. That one right there, also going downhill. That's negative. Why is that? 40 is smaller than 50. Downhill. From 1 to 2. 1 to 2, same reason, that's negative. You don't need the graph. I'm just showing you a way to do it with the graph. And then from 2 to 3. 2 to 3, 65 is bigger than 40. This is positive. Now, I know I have a problem down at the bottom. I'm going to leave that for a different time. We've taken care of the two parts that we needed to. I'm happy with that, and I hope you guys are too. Hope you guys have a great day. Take care. Talk to you soon.